Hey guys, in this video we are going to learn how to program the heat transfer Excel file. So I created this template to kind of help guide you for you to figure out where to be inputting data and equations. So it is color coordinated. So let's start with that first. Anytime you see a yellow cell, that is going to be an area where you input the value. So that'll change problem to problem. So you'll just delete it when you're done with that one. Anytime you see this weird like orangey red color, that's going to be an intermediate answer. So here is where a calculation is going, but this is not necessarily your finished answer. This is just going to be kind of a temporary intermediate answer, which will be used in another calculation to help you get to your final answer. Blue is a reference cell. We're going to reference another cell, so it's just going to be equal to another cell. And then green is going to be your final answer. Typically, these questions are asking you to get the ultimate power or Q prime. Okay, so when you get this problem, you'll be given a layer or a median, we call it, like a different type of substance that heat is transferring through, whether it be a window, a wall, a door, or a roof. So let's start programming it. Our material layer will go here. So here's where you will actually be typing in whatever the first layer is. So maybe the first layer is wood shingles, and then after that is insulation, whatever. Here is, again, because it's yellow, you're entering a value or a word, but you're not entering a calculation. So here is where you enter the R value. R values would go here, and then if it's an R value per unit, you would still put that here. You can read the little blurb here. Here is where you type in the thickness, and over here is where you would get the ultimate R value, which would then be the R value per inch or R value per unit multiplied by the thickness. If it's an R value per unit, you'll put that here, and then you'll set the thickness to 1. That way when it's the R value per unit times 1, it's still the same R value in the end. So in this cell, I'm going to say this is equal to this cell times this cell. And I want to copy that logic down for all of these, but I don't want to type it in every single time. I don't want to say this is equal to this times this and so on. So I'm going to click this cell and then look at my cursor. It's a big white cross. If I go in the bottom right corner, so not this, this, the thin black cross. Click, drag, and hold it down, and that will copy the logic down. So now if I click on any of these cells, the logic is following. So I multiply across and add going down. So the sum right here is going to be equal to SUM. I always like to double click it, and equal to all of these, and then enter. And then my U factor is going to be equal to 1 divided by the R value. And it's giving you a little error message right now. That's just saying, hey, you're trying to do something, or 1 divided by 0, and 1 divided by 0 is undefined. So that's just an error message. It will go away once you actually have like a value here. So I'm going to delete this for now. All right, and let's go to area calculator. Sometimes the area is going to be given as a length times a width. So I'm going to say this is equal to this times this. However, sometimes you'll know the area and you won't necessarily have it be broken up into length times width. So say I know the area is, for example, 24 square feet. I'm not going to type in 24 here because you never want to delete a cell with calculations. If I happen to know the area and it's not broken up into length times width, just enter the area in one of the cells and have the other cell be equal to 1. That way my final answer is the total square footage, and I'm not messing with the calculations, because what could happen is you could save the program, and if you accidentally delete one of the calculations, when you do the next example, it won't be there for you when you do have it in a different format. Okay, temperature difference. This is going to be equal to, I'm at E20, notice the highlighted, equals outside temp minus inside temp. Now, some people like it as absolute value. because the negative doesn't really affect it too much. It's just showing you that the Q is moving in the other direction. So if you want to do absolute value to avoid seeing negatives, you could do A, B, S, and then those two values. That way it'll be the absolute value. Okay, so now we are done with one median. So let's call this the wall. Now, you don't want to have to manually type it in. You want to make everything what we call streamlined. So I'm going to copy this whole section. I'll delete this. And then I'm going to paste it 4 more times. That way I have 5 different medians for each of the 5 different rows I have over here. We typically will try and keep it to 5 or less medians. So I'm going to copy this. So I'm going to highlight everything, and then I'm going to hit Control C. And I'm going to hit Control V. 1, 2, 3, 4 times. It got a little bit smaller over here. That's just because my row height is a little bit different. If I could quickly fix that. So each one's 24. So I'm going to highlight these and just tell it, nah, make the row height 24. Actually, I guess it was the other one. So 18 is what you would be typing in for the row height. There we go. And I'm just going to change this to say median 5. And again, median is just like what the heat is going through. So I might have one median being walls, another one being windows, doors, roof, just to kind of keep it separated. Okay. So now in the blue cells, I'm going to be referencing the different medians. So number 1 is going to be median 1. Number 2, median 2, and so on. So A1 is going to be equal to the area of median 1. So I'm going to say that C7 is equal to 09, the area right here. And then this A2, the second area, is going to be equal to the area of median 2, which is over here. And then A3 is going to be equal to the third area. A4 is the fourth area. And A5 is equal to the fifth area. The U's are going to be the same. So we calculated the U for each by doing 1 over R. So U1 is going to be the U factor for median 1. And it doesn't like it because you're referencing a, well, if you ever get this message, it just means that the column is not wide enough, but it's still going to copy over the error message. But that's fine. In a later video, we will discuss how to add logic to avoid error messages. So back to the program, U2 will be equal to the U for the second median. So that's U right here. It's a little bit harder to copy the logic down. Might be able to do it now, but because it's not successive cells, a lot of times Excel doesn't really do a great job of predicting what you want in that subsequent cell. So I'm just going to do these all manually, although you can kind of follow the trend. So K30, K45, so this one should be equal to K60. But let's verify that. Yeah, because it says divided by 0. And then K75. Because if I go down here, K75 is perfect. Okay. Delta T. Now, every house is going to have the same inside and outside, or sorry, every wall of a house will have the same inside and outside temperature. So that's why we don't really need to copy the temperature difference for every single time, because it's all going to be the same for all walls or all medians of a project or an example. So I'm going to say my delta T is equal to this delta T, and I only have to do that once. And then this cell is equal to this cell again. I could also say that this cell is equal to this cell. I can say that this cell is equal to this cell. It really doesn't matter as long as they're all ultimately referencing E20. Almost done. Now we're going to calculate the individual Q prime, or the individual heat transfer through each median, one at a time. So this cell is equal to A times U times delta T. Copy the logic down. So now this cell, for example, is A times U times delta T for the fifth median. So then we multiply across and add going down. This is equal to the summation of all these cells. So if we start adding some values here, and then we'll do like 70 and then 25, and then we'll do the area as, I'm just throwing in random numbers right now. We notice that we still don't have this giving us our correct final answer. So we are fully programmed right now. However, we are going to go on to our next video. I'm limited to time with each of these videos, given this is a free software. And in that video, we are going to determine exactly how to add logic to get rid of this error message.